Right now, Mars is a frozen, rust-colored desert. No air you could breathe, no liquid water on the surface, nothing alive. A whole planet, just sitting there, dead, red, silent. But give it 200 years, that same red dot in your telescope could have blue skies, green forests, rivers, and the first people in history who were never born on Earth. I know how that sounds, but this isn't science fiction. It's a plan, a real one, with stages. And here's the strange part. Stage 1 is already happening, right now, while you're watching this. So let's do something. Let's climb the whole ladder, every single stage, from the first little robot in the dust all the way to the first ocean. By the end, you'll watch a dead planet wake up. 7 stages, that's the whole journey. Robots, first boots, first base, the first town, the first city. Then the big one, waking the planet up. And finally, a second Earth. And I'm not making these up in my chair. NASA is working on stage 1. SpaceX built a rocket the size of a skyscraper to do stage 2. Scientists at Harvard and in the journal Nature are running the math on the last stage right now. Here's why you should care. This isn't 1,000 years away. The first 3 stages, you will probably watch them happen in your lifetime with your own eyes. So the question isn't if, it's how, stage by stage. Let's start at the bottom of the ladder, where it's just us, a cold rock, and a lot of questions. Before a single person goes, we send the robots. This is the scouting stage, and it's been going on quietly for decades. Think about it. You don't move into a house you've never seen. So first, we map it. Orbiters circle Mars and photograph every inch. Rovers crawl across the dirt, sniffing the air, drilling the rocks, asking one question over and over. Can we live here? And slowly, they keep finding yes. They found water, not puddles, ice, buried ice. So much of it that if you melted what's near the surface, it could wrap the entire planet in an ocean. The water's already there, it's just frozen, waiting. But water's only half of staying alive. You also need to breathe. And the Martian air is poison. It's almost all carbon dioxide, and it's thin. About 1% as thick as ours. So a little robot, the size of a microwave, tried something wild. It sat on Mars, and it made oxygen, pulled it right out of that poison air. It worked 16 times. And the second that worked, everything changed. Because if we can make air there, we don't have to drag it from home. So the robots have done their job. They found the water. They proved we can make air. They drew the map. The scouting is almost over, and that means it's time for the scariest, most beautiful step of all. Someone has to go. The first crew won't be explorers in the old sense. They'll be more like the first nervous guests at a house that isn't finished. They cross space for 7 months. 7 months in a tin can. And then a rocket the size of a building lowers them onto red dirt no human has ever touched. And one of them steps down. That footprint, it stays. There's no wind strong enough, no rain, nothing to wipe it away. That first boot print in the dust could sit there, perfectly sharp, for 1,000,000 years. But here's the thing about that first crew. They can't stay long. They've got what they carried, and not much more. So they do the most important job of the whole trip. They prove a human can survive out there, even for a little while. And then the next crew comes to do something harder. Not to visit, to stay. This is where it stops being a trip and starts being a foothold. You cannot ship everything from Earth. It costs a fortune to launch even a water bottle to Mars. So the only way to actually live there is brutal and simple. Use what's already on Mars. Scientists have a boring name for it: in situ resource utilization. Forget the name. Here's what it means. You make the planet feed you. Remember that frozen ice? You dig it up, melt it. Now you have water, and you can split it into oxygen to breathe and fuel to fly home. Remember that poison air? You run it through machines that pull out breathable oxygen, exactly like that little microwave robot already did. The first base is ugly. A few hard shelters, half buried in dirt to block the radiation. Greenhouses glowing in the dark, growing the first lettuce on another world. It is not pretty, but it is alive. For the first time, humans are not visiting Mars. They live there. And once people live somewhere, they don't stay a handful for long. A base is a job. A settlement is a home. That's the difference, and it's everything. Now more ships come, then more. The shelters connect into tunnels. The one greenhouse becomes 20. Domes go up, clear bubbles holding warm air and green plants against a freezing orange sky. People stop rotating in and out. They start staying for good. They bring tools, art, arguments, music. And then comes the moment that changes the human story forever. A baby is born on Mars. Think about what that means. That child will grow up where the gravity is light. Mars pulls you down with about a third of Earth's strength. They'll watch a sunset that glows blue instead of orange because the dust scatters light backwards there. They'll look up at a tiny, pale sun, and to them, that is home. Earth is just a bright dot, a story their parents tell. That child is the first true Martian. And one town is not nearly enough for what comes next. This is where the settlement becomes a civilization. One town turns into many. They link up. Now you've got roads under the surface, trains between the domes, factories making metal and glass and parts from Martian rock because shipping from Earth is still too slow and too dear. A city needs power, so reactors and huge fields of solar panels hum across the plains. A city needs people who do things, so now there are Martian doctors, Martian engineers, Martian farmers, kids who've never felt rain. And quietly, something deeper happens. The city stops asking Earth for permission. It makes its own rules, its own holidays, its own slang. A new culture born on a new world. But notice, for all of this, people are still living inside domes, inside tunnels. Step outside without a suit, and Mars still kills you in minutes. The whole city is a bubble on a dead planet. And that is exactly the thing the boldest humans refuse to accept. Because here's the truth nobody says out loud at the first 5 stages. Everything so far, the base, the town, the city, it's all camping. Beautiful, incredible camping. But camping. We brought our bubble, and we're hiding inside it, on a world that wants nothing to do with us. And at some point, someone looks out through the glass at that red wasteland and asks the most insane question in human history. What if we didn't have to hide? What if we changed the whole planet to match us? Not a dome, not a bubble, the air, the sky, the temperature of an entire world. This is the line where Mars colonization stops being engineering and becomes something closer to a miracle. Stay with me, because this next part is where the red planet finally starts turning blue. Terraforming. It's the boldest idea we've ever had. And the wild thing is, the plan actually exists. Step 1 is heat. Mars is freezing because its air is too thin to hold warmth. So you make it warmer, on purpose. For years, this looked impossible. But in 2024, scientists ran the numbers on a clever trick. Take Martian dust, shape it into tiny engineered particles, and scatter them into the sky. They trap heat thousands of times better than anything we'd dreamed of. The math says they could warm Mars by 30 degrees. And here's the beautiful part. Warmth sets off a chain reaction. Heat melts the buried ice, so water flows. Flowing water and warmer air release frozen carbon dioxide, so the air gets thicker. Thicker air traps more heat, so it gets warmer still. One push and the planet starts doing the work itself. Then you plant life. Not trees, not yet. First, the tough stuff. Bacteria, algae, moss. Little green things that eat carbon dioxide and breathe out oxygen. They did it on Earth billions of years ago. They filled our sky. Now you let them do it again, on Mars. This stage is slow. We're talking centuries. Honest scientists will tell you the full version might be 100 years away, or 2, or more. But it is no longer a fantasy on a napkin. It's a roadmap, in real journals, with real math. And if you follow that roadmap all the way to the end, you reach the final stage, the one this whole video has been climbing toward. 200 years on, maybe more. Let's go stand on Mars one last time. The sky isn't pink anymore, it's blue. Real blue. There's liquid water, actual rivers, cutting through valleys that have been bone dry for billions of years. There are lakes, maybe the beginnings of a small sea, sitting in a crater that hasn't held water since before life began on Earth. Forests, strange, tough, low forests, spread across ground that used to be poison. And a child walks outside. No suit, no dome, no helmet. They just walk out, and they breathe. They look up at that blue sky, and they have no idea it was ever red. To them, it was always blue. They'll never know their great-great-grandparents crossed an ocean of black space and spent 200 years painting that sky, one stage at a time. That's the whole ladder. Robots, boots, a base, a town, a city, a reborn sky, and finally, a second home for the human race. A dead planet woke up, and we're the ones who woke it. So that's every stage of turning Mars into a new Earth. But I left one thing out, because there's a question hiding underneath all 7 stages, and it's a strange one. Should we do it at all? Some scientists think Mars might already hold tiny life of its own, deep underground. And if it does, terraforming would erase it before we ever say hello. I made a whole video about what we might be sharing that planet with. If you want to know what could already be living under the red dust, watch that one next. Before we go painting the sky. And hey, subscribe if you're the kind of person who wants to understand the future before everyone else does. That's who this channel is for.